Okay, so now we want to talk about the part of adding an element to a linked list, but we want to add the element at the end of a linked list. So we're just going to be building this up from the video that you were already doing from our example. We talked about the part of a linked list that is like this. We have the data here, and this is the next pointer there. So we had about 6 positions that we were dealing with. We had this is A, this is C, this is B, this is D, and this is none. This is none. But this was pointing to 2, so this is 0, 1, 2, 3, 4, and 5. This was pointing to 2, this was pointing to 3, this was pointing to 1, this was pointing to -1, this was pointing to 5, and this was pointing to -1. So this is exactly what we have here, and this is our linked list. And we say this is our start position, and this is our free node, and -1 is this is our start pointer, this is our free pointer, and we said our now pointer is equal to -1. So basically we want to add an element at the end, which means the element that we want to add, let's say that we want to add E. So E is supposed to come through and be at this position, right? So let's just talk about the logic that's supposed to be happening here. If E is now here, it means that my free pointer is no longer this, but my free pointer is supposed to be what is being pointed by this, right? So first thing, I'm going to be using a variable that is called, okay, the first thing that I need to do is, if I want to add E, I'll create a new node, right? I'll create a new node, and I'll call that node now, I'll just make it like this. Is the last element, so it's going to be having node with E, and it's now pointing to -1. That's the node that I want to add into this linked list. So this is supposed to come through and replace this whole junk. So this is supposed to be having E, this is supposed to be having -1, right? That's the next thing that I'm supposed to be doing. But check this part. I can only do this if and only if my free pointer is not -1. If my free pointer is -1, that means that I have no place to add the new node that I want to add. So I have to check. This is only going to be happening if my free pointer, it's going to be happening if my free pointer is not equal to -1. So if it is not equal to -1, that's when I'm going to be doing all this. Otherwise, if it is equal to -1, I'm just going to be saying what? I'm just going to be printing that that can't happen. We can't add, yeah? So we are saying, first of all, we create a node. Then, after I've created a node, I now need to go ahead and reserve this guy here. The next point, I have to reserve the 5 to act as my new next free pointer, because number 4 is about to be given a new node. Position number 4 is about to be given a new node, which means that what it is pointing to, because remember we said the free list is always joined together. So this is the first free node, and it's pointing to this guy. So we now need to reserve our next free. Our next free null is supposed to be equal to the current free node, right? It's supposed to be, we get into the linked list, it's supposed to be the linked list position of the free pointer. We want to get its next node, its next point, right? So we get here and we take the next pointer. That's now my new free. That's going to be my next free, right? So what I now need to do is that I have reserved this. I now need to connect to make sure that this is now connecting to this. I need to change the value of -1 to point to the current free pointer, which is 4. So if this is now pointing to this, it means that this is no longer the last, but this is now the new last. So first of all, I need to connect to this connection now. D is no longer pointing to -1, but D has to point to -4. 2 is now supposed to pointing to 4, which is the current free pointer. Yeah. So to do that, I need to be traversing in the linked list to check who is the last pointer. So I will do that by checking if I will use a variable like current pointer. You know how to traverse a linked list. We already did this. My current pointer is going to be equal to the start pointer. I start with the start pointer, of course. Then I traverse through to say as long as the current pointer is not equal to -1, I need to go ahead and check this part. I need to go ahead and take the previous pointer. Okay, what I need to do is this. If I get to this guy, if its pointer is -1, then I need to change the value of this pointer to point to the next one. So what I need to do is I need to collect this, so which means I will take its current its pointer, which is equals to what? So the current pointer is now equal to linked list position of current pointer. We need to go to dot next pointer. But check this part. What I just did, I'm now holding this. So if this is now -1, I need to change this value to point to the next element. So this value is sitting on this index position. So I need to keep track of the previous pointer. So I'll say previous pointer is now going to be equal to the linked list. Oh, sorry. The previous pointer is equal to the current pointer. So check this part. My current pointer is going to be starting as 0. Is 0 equal to -1? No, it's not. So 0 is now acting as my previous pointer as I go now to number 2. So when I'm now on number 2, my previous pointer will be 0. When I'm on number 2, I'm going to be collecting its current pointer, its pointer again, which is 1. Is 1 equal to -1? No, it's not. So if 1 is not equal to -1, 2 becomes my previous pointer as I go now to what? To position number 1. I hope that is making sense. The reason why I'm doing that is because when I then get to position number 3 to link to the last element, which is -1, my current pointer is now -1. If my current pointer is not equal to -1, previous pointer is still holding 3. Now, if I get out of this loop now, it now means that I can now go ahead and change the value of the pointer who is at 3 because I have reached the end of the linked list. I hope that is making sense. I'm now saying linked list position of previous pointer. Previous like this dot its next pointer is no longer equal to -1, but that's currently where I am at, where I found the pointer to be -1. So I'm now saying its next pointer is no longer equal to -1, but is now equal to pointing at free pointer now. It's no longer -1, but it's now pointing to free pointer. Once I do that now, I can now go ahead and replace this whole thing, this whole part. I can now replace it with my pointer. So a new pointer can now come through and actually stay at the rightful position. So linked list position of free pointer is now supposed to be holding the new node. And once that is done, I now need to go ahead and change now the free pointer to be the next pointer that I had reserved. So free pointer is now equal to the one that I've reserved, saying is the next free. And with that having been said, I can now go ahead and print that I have added my element. I need you to go ahead and actually trace through what we just talked about here and understand it. There are a couple of things that I need to do. First of all, I create the node. Number 2, I reserve the next free, because once I place this element, the new node here, this guy has to disappear. This element here has to be the next free element, because this is no longer free because I have just given it a new node. Number 3, I'm now traversing in the linked list to check which element is the last. Once I get to the last element in the linked list, I change its pointer to point now to where I'm about to place the new node. Once I do that, I place now the new node. Once I place the new node now, I change the value of the free pointer to point to the one that is next free. then I go ahead and print my element is true. This is only happening if there was a free pointer to begin with. If there was a free space to begin with. It did mean that there is no free space, then I have to be cancelling out and actually logging out, saying that I can't add that. So this is the pseudocode for that, but this is the Python code for that. We are adding an element, and we are taking now, we're going to be making use of the global free pointer. So we're saying if the free pointer is not equal to -1, which is our null pointer, we're going ahead to create a new node. After creating a new node, we are reserving the next free, and we are now traversing in our linked list now to check the last element up to this point. And we are reserving again our previous pointer so that we can change the free point, the next node of the previous pointer, the last pointer of the last node, I mean to say, its next pointer is now supposed to be the free pointer. This is the element that we were talking about here. After we do that, we need to go ahead and add the new node. That's what we just did now. We just placed the new node on its rightful position. And after that, we change the value of the free pointer by saying free pointer is null equal to next free. Free pointer is null equal to the next free that we had reserved here. So at the end of the day, we can print that the element that we took here has been added successfully. Otherwise, we are printing that the list is now full. I hope you have taken this down, and you can code this. And I'll just clear this so that I can run the code. Of course, I have my code for output so that I can be able to go through the elements. So all this wasn't really necessary, was it? Yeah, it was necessary or it wasn't necessary. Either way, you can just do without. Even the part on add, on searching an element, we already did the part on search. I understand that you have these codes. Let me see if I remove those globals, if I see if this is going to be causing an error. No error. Still, you can actually run this without using globals. So if I'm going to be running my code, it's presenting no error. So if I first say output, just to check if all my elements are actually being displayed. Currently, I have only A, B, C, and D. If I go ahead and add an element now, let's say that I want to add an element E. If I run that, it's telling that E has been added successfully. If I run output, I'm now seeing that there is an E that has been added. Let's go ahead and input another element, which is EF. We run that, F has been added successfully. If we output, we are seeing that F has been added successfully. Let's try to add, we only had 2 spaces that were free here. Let's try to see what will happen if we have our elements now coming through. If we're going to be adding another element, let's see what's going to be happening. Oh, I don't know what's happening there. Let's go ahead and do the part of add element, and let's add another element, which is maybe T. And what is this going to be telling me? It's going to be telling me that the linked list is already full. Why? Because we only had 2 empty spaces that we could actually use. But suppose that we want to have more free space, we could actually create more free space there. So that's basically how we do it whenever we want to want to add an element. Just go through the code again, go through the video quite a number of times. Just to put a disclaimer, I actually thought twice of actually putting this in video, because I usually want to teach this in real time, seeing your reactions as I'll be teaching, so that I can correct wherever you'll be having questions. I can respond to live questions if they are there. But we did it anyways. Just go ahead and actually watch the video once, twice, maybe thrice before you actually can understand. Don't cram the code. You need to understand exactly what's happening in the code, because it can be twisted a little bit, but the logic remains the same. The logic remains the same. You want to be seeing this coming through maybe in 2D arrays, in 1D arrays, and right now I just gave an example using classes. Either way, you're just supposed to be able to know the logic that is happening. And the first part of the video that he had the pseudocode is the one that is mainly that is most important. You need to know the logic behind before you start to answer the question. Anyways, let me not make this video any longer. If you have a question, please hit me back. Go ahead and write this code and test it as many times as you can, and even change the values of you can even increase your linked list and see how it's going to be like. And if you can write the code any shorter, that would be an advantage. to ISO. You can even tell me your logic that you have so that we can actually celebrate the improved time complexity and space complexity, of course. All right, thank you.